I welcome you all for today's session on ceramics. As we all know that a ceramic is an inorganic non-metallic solid made up of either metal or non-metal compounds that have been shaped and then hardened by heating to high temperatures. In general, they are hard, corrosion resistant and brittle. It is possible to obtain ceramic materials of any required properties, mechanical, electrical, chemical or magnetic by suitable processing techniques. Hence, it has a wide range of applications. Now we will discuss how ceramics are processed. The figure which is being shown here represent a ceramic processing steps. Initially, the raw material that is being utilized for ceramic is naturally occurring rocks and minerals. And by following the operations like crushing and milling, the ceramic particles are formed into a desired shape, and this is followed by the addition of water and additives such as binder, lubricants, wetting agents, and followed by a shape forming process. Some of the shape forming process that is being followed in ceramics includes slip casting, extrusion, pressing, injection molding. Prior to firing and sintering, ceramics are often heat treated at a temperature well below firing temperatures. The purpose of this thermal processing is to provide additional drying to vaporize or decompose organic additives and other impurities to remove residual, crystalline and chemically bound water. After the particles are formed, this green ceramic undergo a heat treatment called firing or sintering to produce a rigid finished product. Some ceramics for advanced application may undergo a machining or polishing operations in order to meet specific engineering design criteria. In today's class, I will be discussing on various forming processes, that is shaping methods. So many shaping methods are used for ceramic products and these can be grouped into three basic categories. First one is powder compaction, another one is casting and another one is plastic forming. And the example or the process that has been carried out in powder compaction is dry pressing, hot pressing, cold isostatic pressing, hot isostatic pressing, etc. Whereas in casting, where the molds will be utilized and by containing a liquid or slurry or slip, the casting will be carried out. Example is slip casting or gel casting, electrophoresis casting, etc. Whereas when it comes to plastic forming, where some of the process that is been carried out is extrusion, injection molding, transfer molding, etc., where it utilizes a pressure to shape the green ceramics. Now I will be explaining on powder compaction. In powder compaction, the ceramic or metal in the form of fine powder is mixed with small amount of water or other binder and is compacted into the desired shape by applying high pressure. The powder may be dry pressed, that is without the addition of a binder, or pressed with the addition of small amount of suitable binder. Simple shapes are made by applying the pressure uniaxially, where the pressure will be applied in a single axial direction through a punch or piston. And if you want to get a more complex shapes, then we go for isostatic pressing. Isostatic pressing is where the pressure will be applied uniformly in all direction through a fluid. Isostatic pressing can be of two types. One is cold isostatic pressing, another one is hot isostatic pressing. Cold isostatic pressing works at room temperature, and the process in which I will be explaining the cold isostatic pressing is a wet bag process. The wet bag process construction is being represented here. It comprises of a bottom closure, top closure, high pressure vessel, rubber mold. Inside that a powder is being filled, a pressure medium. The stepwise process of a wet bag process is being represented here. It comprises of 4 steps. Initially, the ceramic or other powder, fine powder is being filled inside the mold, and that mold is being placed inside the vessel, and the vessel is of high pressurized container. And after that, the vessel is being airtightly sealed. And next, in the third step, the isostatic pressure is being applied to the outer surface of the mold, due to which it compresses the powder into a desired shape. And under the high pressure, the material are formed and densified. So that is how the process in wet bag process takes place. That is step 1, step 2, step 3 and step 4. And why we go for cold isostatic pressing is it has some advantage for producing parts where high initial cost of pressing dies cannot be justified, or when very large or complex compacts are needed. At that condition the cold isostatic pressing will be followed. The video which I am going to show here is an isostatic pressing process animation. That is what I explained. Stage 1, where ceramic powder is fed into a molding bag inside a container. Next, it is being what? It is being placed inside the mold cavity. After that, what? Stage 2, the press is then sealed. That is, it will be placed inside the vessel, or it will be sealed here. You can see here. It is being sealed. And the pressure is then applied which compacts the powder. The pressure will be what? It will be of isostatic pressure, where the pressure will be applied in uniform direction in all the direction. Stage 4, where the pressure is released and all that remains is the solid formed ceramic component. This is the solid formed ceramic component. Yes. This is how the process works. So now I will be explaining on hot isostatic process. The figure indicates the hot isostatic process where it works on three stages: stage 1, stage 2 and stage 3. In stage 1, a container with powder is being used to fill the capsule. This is the capsule and which is made from sheet metal. This capsule defines the shape and size of the product to be developed by this process. Usually the capsule is stick welded to ensure gas tight welds of high quality. In stage 2, the vacuum pump mechanism is utilized to remove any air or any gas particles from the capsule that creates vacuum in the vessel. After powder is been filled, the capsule is been sealed and separated from the vacuum pump. In stage 3, the capsule will be placed inside the pressurized vessel at a temperature of 1100 degrees Celsius with a pressure of 1000 bar. During hot isostatic pressing, the pressure is being applied to a material uniformly in all direction through a inert gas. Usually argon gas is being utilized here. Throughout the process, the heat is being applied to the containment chamber such that the temperature that is being employed here is below the melting point of the material being used. The reason for applying the pressure as well as the temperature simultaneously because to eliminate any small gaps or any pores in the material and hence to increase the density and uniform composition. Usually the temperature which is been maintained here, that is 1100 degrees Celsius and 1000 bar. It is mainly considered for a steel for steels, many steels, because at this particular combination the results that is been obtained is of good quality. And here another figure which I have represented here, it represents the capsule and the final product which has been obtained by following stage 1, stage 2 and stage 3. This is the final product that has been obtained. So now I will be explaining on slip casting. So what do you mean by a slip? Slip is nothing but is a suspension of ceramic powder in water. You can see here a suspension of ceramic powder in water is called as a slip. It is poured into a porous plaster of Paris. The working principle in which the slip casting work is where the slip will be poured into a porous plaster of Paris mold so that water from the mix is absorbed into the plaster to form a firm layer of clay at the mold surface. This is how the working principle of a slip casting works, where the slip comprises of 25 to 40% of water. The slip casting can be of two types. One is drain casting and another one is solid casting. Drain casting is used to produce a hollow product. Solid casting is used to produce the solid products. And the application in which the slip casting is used to prepare flower pots, lamp bases, toilets, etc. And first thing is what I am going to explain is on drain casting. The figure which indicates here, which works under three stages: stage 1, stage 2 and stage 3, where the slip is poured into a plaster of Paris mold cavity. So this is the mold cavity and where the slip is being poured inside it. Next, in stage 2 or step 2, where the water in the slip is being absorbed into the plaster mold to form a firm layer. Next, in the third step, the excess slip is being poured out. By reverting the mold, the excess slip will be what? It will be poured outside the mold cavity, and thereby the green body is being obtained from the mold, and it will be hollow in nature. By following the drain casting, the hollow model or hollow object will be obtained. The solid casting. The working principle of solid casting is same that of drain casting, but initially the first two stages are same here. That is, slip is poured inside the plaster of Paris mold cavity. Here also the slip will be poured inside the mold cavity. Next, in stage 2 is what? The water is absorbed into the plaster mold, stage 2. But in stage 3, what we used to do in drain casting, we used to tilt it or revert it back so that the slip will be drained, excess slip will be what thrown outside from the mold cavity. Whereas in this solid casting, the adequate time is allowed for entire body to become firm, so there will not be any reverting of slip. Whatever the slip is being poured inside this mold cavity will be retained until it becomes a solid object, and that will be removed from the mold to obtain the final object. So to separate the part from the mold cavity, a mold releasing agent such as oil, starch or graphite will be utilized initially to the molding box. And advantage of following this type of slip casting is what? It can be used where shapes are in size that cannot be possibly pressed. And disadvantage is what? The process is slow and there is a limited commercial application of this kind of casting. Video which I am going to show here, you can see here the type in which the casting can be made by this kind of slip casting is what? The turbine blade preparation can also be made by using this kind of casting process. And the image, the video which I am going to show is a slip casting process. Slip casting process has been shown here where the two mold blocks are joined together and a slip is being poured inside the cavity. Excess slip is removed, but adequate time is allowed for entire body to become a firm and get a solid object. So some finishing operation will be carried out, texturing of the object will be done, and finally the product will be obtained, and that is how the slip casting will be done. So now I will be explaining on tape casting. Tape casting is a primary forming method which is used to produce thin white ceramic tapes of thickness less than 1.5 mm. It is also called as doctor blading and knife coating process. The working principle behind the tape casting is where the slurry is cast over a moving plastic belt while its thickness is controlled by blade. You can see the working principle of a tape casting where it comprises of a slurry, a drying chamber, tape carrier, a take-up roll, and where the blade is been mounted with micrometer screw gauge. All has been represented here, and the working process in which the tape casting works is been represented in this figure, where initially the ceramic powder which has been mixed with a solvent. Here it has been mixed with a solvent. Next, it has been placed inside a vessel where it has been added with binder and additives to form a slurry. That slurry is being supplied to a homogenizing chamber. In homogenized chamber, where it get reduce the size of the particles for making same and similar shape and size, and then the whatever the mixture is there, it is being pumped directly to a tape casting machine. There the slurry is continuously cast on the surface of the moving carrier film. The edge of the smooth knife, here you can see here, the edge of the smooth knife, generally called the doctor blade, spreads the slurry onto the carrier film at a specified thickness, thereby generating a flexible tape. Heat lamp gently evaporates the solvent and dry tape is being peeled away from the carrier film and rolled over to take up the reel for additional processing. It is used to produce thin white ceramic tapes. So now I will be explaining on injection molding. So injection molding is a manufacturing process in which the parts are produced by injecting molten material into a mold. So injection molding is used extensively for the precision forming of ceramics in high technology application and such as rocket engine components, dental implants, etc. The working principle of injection molding process has been represented here, where it follows different stages. Initially, before injection molding, the fine ceramic powder is mixed with a polymer binder, such as thermoplastic polymer or wax, to form a homogeneous mixture. This mixture is granulated to form a feedstock. This feedstock is heated to form a viscous slurry and injected to the mold to form a green part. The part of the binders are removed through solvent debinding to get a brown part. This process begins with the removal of the soluble binder components by using solvents such as heptane or hexane. And next step is what? Pre-sintering. And pre-sintering is done where heating the green compact is done to prepare the powder shape by burning of the binder. And the brown part which has been obtained is densified through a sintering process to get a finished part. A video which I am going to explain is on injection molding process. Initially you can see here in injection molding, what is the first step? The first step is what? Mixing. Ceramic powders and organics are added to a special mixing device and intimately mixed together. So this is the device, right, where the mixing takes place. Ceramic powder, binders, all will be added, and thereby mixing of both takes place. And now what is the next step? The next step is what? Material preparation. The mix is then granulated, right? So what do you mean by granulated? Where the whatever the mixing has been happened, that will be what? It will be granulated in such a way that the output that has been obtained here, that output will be in the form of a pellets. That is formed into a uniform pellets. And that pellets has been what? Fed into the chamber to form a feedstock. These pellets are then liquefied and forced into a mold. So there is a heating chamber here. So when it has been forced, it gets liquefied and it will be supplied to a mold chamber or cavity, and thereby the final component will be obtained. And next step is what? Debinding is placed into a high temperature and the binders will be removed. So by placing into a high temperature also the debinding can take place, or else by following the solvent debinding process also can be done. Next is what? Pre-sintering. The pre-sintering and debinding process one and the same, where it will be heated to some temperature, whereas the sintering process is where the intense heat will be applied to the molded components and thereby it shrinks up to 20% of its original shape. So while designing, initially the shrinkage percentage has to be considered and thereby the final shape or size will be obtained. So now I will be explaining on extrusion process. Extrusion is a process where a material is pushed through a die of the desired cross section. The extrusion process follows three stages. The initial stage is where the powder is mixed with a binder to form a crumble type consistency. And in the second stage, the ceramic mix powder is added into a chamber where it is sealed and air removed to create a vacuum. And the third stage is where, using a ram or plunger force, the plastic mix of a ceramic powder is forced through a constricting die to produce a elongated shape that have a constant cross section. The two main advantages of this process over other manufacturing processes are its ability to create very complex cross section and to work material that are brittle, because the material only encounters compressive and shear stresses. The video which I am going to show here represent a extrusion process animation. So here also it represents the three stage how it works. Initially the first stage is where the ceramic powders and binders are mixed together forming a crumble type consistency. You can see how the mixture is taking place. The crumble type consistency will be maintained here. The mixture of ceramics and binder. Stage 2 is where the ceramic mix is added into a chamber, it is sealed and air removed to create a vacuum. Here, the chamber inside which the mixture is being placed, and it will be sealed, and where the air will be removed to create a vacuum. A ramp pushes the mix through a shape tooling at the end to form a tube shape. That is, the required cross section will be obtained the where the mixture is being forced through a constructing die to produce a elongated shape that have a constant cross section. That is how the working process of extrusion process takes place. So now coming to the ceramic application, the ceramic applications can be categorized into two types. One is traditional ceramics application, and second one is advanced ceramic applications. Coming to traditional ceramics, the ceramic materials that are derived from a common naturally occurring raw material such as clay, minerals and quartz sands. The traditional ceramics are used in pottery. The types of pottery are earthenware, stoneware, porcelain, etc. So you can see here the images which I am going to show here, which is being used by traditional ceramics, which is used for building materials, ceramic wall tiles, swimming pool, ceramic tiles, etc. And also in space shuttle, silicon material tiles are being used because of their low thermal conductivity, high temperature capability up to 1400 degrees Celsius. It is therefore it is being used in space shuttles. And also you can see here it is used to make bathroom fittings. All the fittings are being used by traditional ceramic materials. So, the traditional ceramic materials are usually a clay based, whereas when it comes to advanced ceramics, it is not a clay based. Instead, they are either based on oxides or non oxides or combination of the two. Typically, oxides that are example for oxide based advanced ceramics are alumina and zirconia. So alumina, it is the most widely used oxide ceramics. It is used as a refractory material for high temperatures, spark plug insulators, centrifuge lining, thermal barrier coatings, plane bearings, etc. Whereas zirconia, which has been used in grinding ball mills and which is also used as sensors in automotive. In modern medicine, often referred to as bioceramics, these two materials are used because they are hard, chemically inert materials that can be polished to a high finish. They are used as dental implants and as a bone substitutes in orthopedic operations such as hip and knee replacement. Coming to non-oxides, examples are carbides and nitrides. The nitrides, the example is cubic boron nitride. It is the hardest material which is next to diamond. It is used for cutting tools and as abrasive in grinding wheels. Titanium nitride is used as a coating material on cutting tools. Silicon nitride, it is used for high temperature application such as automotive engine, gas turbine components, turbocharger rotors, bearing, etc. When it comes to carbides, tungsten carbide with cobalt as binder is used for cutting tools and dies. Silicon carbide is used as abrasive and for heat engine components. So we have discussed a lot from how the ceramics are processed, different shaping techniques in which the ceramics are processed and its applications.